Alright, so that is everything wired. This light here, there we go. That's everything wired. There were some little fiddly bits right around here where I kind of had to go over and under and swoop around, so I just covered those up with a little bit of hot glue because they were at kind of an odd angle. I might also do this one. But that took 55 minutes, 24 seconds, and that was using those, using a few of those little sets that will go across, and also pausing to take a phone call and do that testing video, that short testing video, which I'm going to expand upon right now. So again, we're testing real quick, done wiring. We're going to test before we put the teensy on. Oh. So, touching one row, touch the other side of the row. Good. Now I'm going to touch each column. And it's good to touch in another spot. Actually, it's not. And no beeping. Now what we'd be looking for is if this one was laying down and touching, I would touch this column and it would short. This row would be connected to this column. We don't want that. Column, column, nothing. Next row. Column, 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 column. Good. That was me just scraping touching the row. Nothing on the row. Ooh, here's one. So we see this column is connected to this row. So this point is touching. So we'll lift it up, push down that diode. Now it's not touching, but it's still kind of close. Close for me. So let's hit it with a little bit of hot glue. Again, I'm getting the hot glue between the two wires and around the two wires, so that when it hardens, those two wires are encapsulated, top, bottom, and in between, with layers of glue. So they're really not going to press, or really not going to touch, even if you push on them. It's that column again, same column, push, 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 nothing. Next column, next column. Ooh, look at that. That's a bad joint. Just popped loose. I got a little quick on some of these, so it wouldn't surprise me if some of these popped loose. But 54 minutes, or 55 minutes. So what are you going to do? I'll take that. Column, column, column. Oh, that's actually kind of sticking out. There we go. You get out of here. Row, column, column, column. Good. Next row. Row all the way across is good. Row all the way across is good. Column, 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 column. I just grazed the row, I think. Yep. Good. Next row. Good connection across. Check columns. Check the intersections. Technically, I should be checking right along the row because I haven't checked these columns, but for the columns. But the columns are single core wire, so they're always going to connect. And the top row doesn't really have any intersection with columns, so just check across and we're good to go. Columns are single core wire, so I'm not even going to check them, but this is how you would touch top and bottom. Come on. There we go. Good all the way across. So the next thing we're going to do is get oriented. When we want to program this, we're going to program it using EasyAVR, and I would like this to be top left to be 0, 0. So our columns are vertical, so column 0 is this one, and row 0 is this one. R, C. 1, 2, 3, 4. R4, column 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is a 5 by 15, so obviously 14. 14 columns, including 0. C14. R4, R0, column 0, column 14. And for any of these, while we're looking at it, for any of these weird ones, like these ones are kind of in the middle, we can trace these and just identify these. Column 0, 1, 2, 3, 4, 5, 6, 7. Column 7. Row 0, 1, 2, 3. 0, 1, 2. Row 2. Just labeling some of these just makes it a little easier. So we notice that this switch is kind of in the middle of everything. It's definitely column 7. And we can write C7 here. However, it is connected to row 1. R1. This one's in the middle. It's pretty obvious what the connection is because it lines up with everything. But this one is not as obvious. So column 7, 8, 9. And that connects down to here. So this is C9. And then the row is row 4, which is obvious. This one, column 7, column 6. This one connects down to here. This is C6. So we've got labels on these things. This is connected to R2 to make the next step easier. And the next step is we are going to be mapping this out and identifying where we're going to need connections. So I'm going to be using this teensy. I'm probably going to be dropping it down here. So it'll be down in the middle because I don't know, reasons, I guess. I like low profile. It has a really low profile that I really like, so I'd like to maintain that if possible. But not sure how much room we have to accomplish that. You can also take these leads and bend them so that they're flatter. They stick up a bit, but you can just push them flat down, as flat as you can, and then solder just kind of surface onto them. It's a good way of doing it. But at this point, we're going to start plotting out what goes where. So here's our teensy. This already has a bunch of stuff on it. And your most useful tool when programming these things, paper. Lovely paper. I would highly, highly, highly recommend soldering in such a fashion that these wires are coming out from ports that are obvious, or from I/O ports that are obvious. So it's pretty easy to tell which port this wire goes to, or which I/O pin this wire goes to, and this one too. That also means that you can take pictures and review the pictures later when you need to, in case you get lost. But I'm a fan of doing it this way. I'm also a fan of fan of doing it this way because it labels everything properly, but I'm also a fan of doing it this way by writing your pinouts on a piece of paper. You get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 down, and 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5 across. 5, and then 12 back up. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. And I've done this wrong already. 1, 2, 3, 4, 5, 6. I think I put an extra 2, 3, 4, 5, 6, 7. Yep. Put an extra one in the middle there. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all I've done is indicated my dots. That's it. Now I can place this and then identify where I need to go longer or shorter. We should also be planning out how many connections we really do need by determining how many rows and columns we have. So in this case, we've got 15 columns and 15 columns and 5 rows. So it's actually just 15 plus 5 because you need a different connection for each column and each row. So we need 20 connections, which we have. So the next part is kind of identifying where your reach needs to be. And you can take your longest ones, that one's a pretty long one, and see how far you can reach and solder new wires onto there if you need to. It's generally better to have the full insulation all over the wire, so I might solder a new wire to the end of this one, but that would leave an exposed connection here, which might tap against this when I'm pressing down. So plotting this out is important and allows you to get kind of a lay of the land. Now, I did mention the possibility of putting it upside down like this. If I did that, I would want to turn this upside down and fill it in that way, because this orientation will get you confused if you let it. So don't let it. I think I will actually reduce this, cut this down, and then put it down in the middle for some reason, because that looks kind of silly, and sure, why not? So I'll come back after I've done that.